Hello everyone! Welcome back for another presentation. Today we are going to be doing a little experiment with some balloons, one with water, one with air. Full disclaimer, I am terrified of balloons popping and of fire, so I'm not actually going to do the fire under the air balloon, but I'll explain everything that's going to happen and we'll do the fire under the water balloon. So the goal of this experiment is to look at how different things have different heat capacities and how things handle heat differently. So the first thing we have is just a balloon filled with air. So if I were to take this lighter and to light a fire under here and bring it real close, the balloon's gonna pop immediately. And the reason for this is because air is a terrible conductor of heat away from items. So it's not going to take away the heat from the rubber very quickly. And we're going to see a physical reaction from the rubber, which is the rubber effectively just splitting. The fibers are going to pull apart. So that's why if you light a fire under a normal balloon, it will pop. But we also have here a water-filled balloon. So we're going to see what happens here. I'm going to move my notebook just in case, the hypothesis is wrong. Oh boy, can we get the lighter to work? There we go. Okay. So, as you can see, nothing's happening. It's a little toasted under there, but otherwise, nada. It's not even warm to the touch. So let's talk about why. The great question. Why does that balloon not pop, but the one with air does? So the reason behind this, like I said, this is an experiment about heat capacity. So heat capacity is how much heat is needed to raise the temperature of something, to put it simply. So the heat capacity of water is going to be higher than air, which is why, one of the reasons why the water balloon is not going to pop. The other reason why, that kind of very much relates to this, is called a convection current. So this is what happens when water is heated. It rises because heat generally rises and cools off, sinks back down. So it kind of makes that up and down convection current. So essentially what's happening is instead of the rubber of the balloon getting really, really hot and overheating, the water is taking that heat and pulling it away and moving it elsewhere, then rotating cooler water back down that once again cools down the rubber there. So kind of a cool mix of things that are happening there. It's a really nice, easy way to show heat capacity and how much of an impact that can have on everyday life. So if you're having a water balloon fight and you want to try and pop their balloons, fire is not the way to do it. This is an interesting concept as well because it can be applied into real life as well. So coastal land and inland, you're generally going to see a little bit better heat management on the coast for that same reason of the water pulling away some of that heat from the land. I'm sure you all have experienced this before, but when you walk onto a beach, even if it's, a white sand beach, it's burning hot. You run to the water, and the closer you get, the more moisture. It gets cooler and cooler and cooler. And generally, the temperature is a little lower at the beach than it is, say, an hour inland. So that's a very applicable way to look at this concept. Another thing to note is that just because there is water in this balloon, it does not mean that it's unbreakable. If I were to come up here and heat up where there is air and not water, this would burst for the reasons that we've talked about. There's no water up there to cycle it through. So even though there is water in here, it's not going to be enough to pull away that heat if I'm putting the heat directly where there's air in rubber. So kind of a cool experiment. Sorry I couldn't pop the first balloon, but theoretically that would be what happens. So if you want to see that, you can check out some other videos of that. But the air balloon would pop. The water balloon will not pop with heat because of the convection current and heat capacity of water. So I hope you enjoyed this video and the explanation of why that happens.